Hello everyone. What should be a good oscilloscope? Fast, accurate, with sufficient bandwidth, with convenient control and, preferably, inexpensive. This is the kind of oscilloscope I will show in this video. This is a digital oscilloscope with a multimeter function from ZOE and Zotec. Its model is ZT702S. In its category and in its price range, this oscilloscope, without exaggeration, is one of the best. In some of its parameters, it is quite comparable with more expensive professional devices. Now it is actively sold almost all over the world. And in the description under this video I will leave a link by clicking on which you can find out more information about it and, if desired, purchase it for yourself. Well, in this video I will show in detail what he is capable of. The ZT702S oscilloscope comes in such a nice looking box. On the one hand, the device is depicted in the oscilloscope mode. And on the other hand, in the multimeter mode. Inside the box there is a cloth case in which it is convenient to store the oscilloscope and its accessories. And here is the complete set of this device. An oscilloscope probe. Quite a standard probe. Good quality. A long cord. This probe is with a divider of 1x, 10x. There is also a screw for calibrating the divider. Instructions are attached to the probe. Calibration screwdriver and plastic tips. Probes from multimeter. The wire is very soft, long. But the sting of these probes deserves special attention. It is very sharp and has a golden coating. The measurement limits of these probes are 1000 volts and 20 amperes. The probes in this device are of excellent quality. There is also a thermocouple of this type. A very convenient thermocouple by the way. USB Type-C cord for charging and connecting the oscilloscope to a computer. And the user manual. It is quite voluminous and with color illustrations. Exactly half of the instructions are devoted to working with an oscilloscope, and the second half tells about the multimeter and the characteristics of the device. Let's look at them in more detail. First, the parameters of this device are indicated in the multimeter mode. Measurement of constant voltage up to 1000 volts. The margin of error is 0.5%. Measurement of AC voltage up to 750 volts and an error of 1%. By the way, this is a very good indicator. More expensive multimeter models are no different in this regard and have the same parameters. The following is very important information. This multimeter has a true RMS function. That is, it can measure voltage and current regardless of the waveform and at high frequencies. But it is honestly stated here that the frequency range in which this multimeter makes accurate and adequate measurements is from 40 Hz to 1 kHz. Beyond these limits, measurements can be with a large error. Measurement of DC current up to 10 amps and an error of 1%. The measurement of alternating current is also up to 10 amps. And the error is slightly more. 1.2%. Next, the resistance measurement, up to 100 megohms. The margin of error is 3%. In the main range, the margin of error is 0.5%. Measuring capacity up to 100,000 microfarads or up to 100 millifarads. The margin of error is 5%. In the main range, up to 1000 microfarads, the error is 2%. Frequency measurement up to 1 MHz. The margin of error is 0.1%. It is also noted here that this multimeter can measure temperatures up to 1000 degrees Celsius. Check diodes and check the electrical circuit. The following page shows the characteristics of this device in the oscilloscope mode. The bandwidth is 10 MHz. Someone may think that this is not enough, but in fact, for the absolute majority of radio amateurs, an oscilloscope with such a bandwidth will be more than enough. Sampling method or sampling is real-time. The sampling rate is 48 megasamples per second. This is also an excellent indicator. It will be convenient and comfortable to work with such an oscilloscope. The oscilloscope is single channel. It would be nice if it had 2 channels, but we have what we have. This oscilloscope is single channel. The entrance is open and closed. The input impedance is 1 megohm. The capacity is 16 picofarads. Divider x1, x10. The maximum input voltage is 150 volts. This is without a divider, and with a divider, the maximum input voltage will be, as indicated on the oscilloscope probe, 300 volts. Next, the scan. From 100 nanoseconds per division to 20 seconds per division. Vertical scan. From 20 millivolts per division to 10 volts per division. These are also wonderful parameters. It is indicated that the oscilloscope can measure the period, frequency, amplitude, maximum and minimum values. Trigger mode, automatic, normal and single. Well, this device has remarkable characteristics both in multimeter mode and, most importantly, in oscilloscope mode. It is safe to say that the ZT702S oscilloscope is one of the best in its category. Now let's take a closer look at the device itself. The appearance and color combination is very pleasant. There is a stand on the back side. The red material is rubberized, and the black is plastic. In the upper part of the device there is a full-fledged BNC connector for connecting the oscilloscope probe. Here is a Type-C connector and a test output of a rectangular signal with a frequency of 1 kHz. The ZT702S oscilloscope has a large 2.8-inch color screen. There are 4 function buttons located under the screen. Then the on and off buttons, additional modes, menus and arrows to control the oscilloscope. At the bottom of the oscilloscope there are 4 connectors for multimeter probes, common, main and 2 connectors for measuring currents. To turn on the device, you need to press and hold this button for a couple of seconds. When turned on, the device is loaded in the oscilloscope mode. This suggests that first of all it is an oscilloscope, and then a multimeter. The viewing angle of the screen is very good. Let's see what information is on the screen. The first icon is the scan status indicator. Run means that the scan is enabled. This strip graphically displays the device's memory. Next, the speed of horizontal scanning, that is, the time for one division. The next icon is vertical sensitivity. That is, it means voltage by one division. Then the synchronization level. This level is also displayed on the chart with this green triangle. The icon of the battery charge level. The lower part shows the frequency of the signal, the amplitude of the signal from peak to peak and the maximum voltage. The buttons under the screen are used to control the oscilloscope. The buttons from F1 to F4 correspond to these icons at the bottom of the screen. Depending on the selected measurement mode, the functions of these buttons will change. The current parameter is displayed in orange and can be adjusted using these arrows. Now I will connect the probe to test the oscilloscope. On the oscilloscope screen we see a rectangular signal with a frequency of 1 kHz. The voltage from peak to peak is about 3 volts. And the maximum voltage is also about 3 volts. Now, when pressing the F1 button, that is, when the well time item is selected, you can use the control buttons to adjust the sensitivity of the oscilloscope vertically and the scan time horizontally. The F2 button turns on the move item. Now, using the control buttons, you can move the waveform horizontally and vertically. The F3 button is a trigger. Now we can change the synchronization voltage, which is indicated here at the top of the screen and is also indicated by this green stripe. This strip can be moved with arrows. When it goes beyond the waveform, synchronization is disrupted. When the strip returns to the waveform area, synchronization is restored. The F4 button is the operating mode of the oscilloscope input, that is, open or closed input. AC mode is a closed input, that is, the alternating voltage is displayed on the waveform, and the constant component is cut off by a capacitor at the input. DC mode means open input. In this case, the oscilloscope shows both the alternating voltage and the constant component of the signal. These are the main 4 functional features of the ZT702S oscilloscope, but there are additional ones. For example, by default, 3 input signal parameters are displayed on the screen: frequency, amplitude, and maximum voltage. When you click the menu button, additional parameters appear. Now, using the F1 to F4 buttons, you can select the corresponding items on the screen, and using the left and right arrows, you can scroll through the menu pages. Now we need this item more ms, that is, more measurements. To turn it on, press the F4 button. Now additional parameters of the waveform are displayed on the screen: the minimum voltage, RMS, that is, the effective value, and the period of the signal, or the time of one complete oscillation. Well, since we have already reached the menu, then we will consider its other items. The first point is switching the oscilloscope input to open or closed mode, that is DC, AC. This item duplicates the F4 button on the main screen of the oscilloscope. The next item is the scan mode. The automatic mode is now set. You can also choose manual mode and single mode. Next is the trigger. The waveform will be shown on an ascending or descending front. The next item is the divider. When you turn on the divider, you need not only to shift the switch on the oscilloscope probe, but also to change the value programmatically. The next page, and here are a few settings. The system language is English or Chinese. Auto off. Screen brightness. And the item already familiar to us is enabling and disabling additional parameters of the oscilloscope. Another menu page, and here the first item is calibration. When pressing the F1 button, the oscilloscope will automatically calibrate the oscillogram for about a minute. Make certain settings so that it is displayed most accurately. F2 button, reset settings. The F3 button is used to transfer data to the computer. This oscilloscope can take screenshots and then save them as graphic images, which can then be viewed on a computer screen. In order to save the image on the screen, you need to press and hold this button. The screenshot is saved in the device's memory. Now, to view it, you need to press the F3 button and connect the oscilloscope to the computer. The computer defines this oscilloscope as a data storage device. And now you can study the saved waveform snapshot in detail on the monitor. And the last menu item is the firmware version. Now I will check how this oscilloscope displays other waveforms. I will connect it to a tone generator and will give a signal of different frequencies and different shapes. The sine wave is 440 Hz. The oscilloscope in this device is excellent. Now let's check which multimeter is here. To switch to the multimeter mode, press the mode button. The multimeter screen looks unusual, but it is very interesting. There is both a digital scale and a pseudo-analog scale. Now I will connect the multimeter probes to check some of its operating modes. Just as in the case of an oscilloscope, the F1 to F4 buttons switch the corresponding items indicated at the bottom of the screen. The first mode is the measurement of DC and AC voltage. The voltage of this battery is 1.1 volts. This multimeter automatically determines the required measurement range. Now I will connect the power supply. You can see how the multimeter goes from units to tens. You can also switch the required measurement mode in manual mode using this button. Millivolts, units, tens of volts and hundreds. To return to automatic mode, you need to press and hold this button. To measure the AC voltage, press the F1 button again. The mains voltage is 250 volts. The F2 button enables the following measurement mode, which combines several items at once. Resistance measurement, electrical circuit check and sound signal, diode check and capacitance measurement, resistance at 47 kiloohms. The multimeter shows 48 kiloohms. Next, check the circuit and beep. It works perfectly and there are no delays. Checking diodes. I'll check the transistor. The transistor is serviceable and this measurement mode in this multimeter works wonderfully. The next mode is capacity measurement. A 10 nanofarad capacitor. Exactly 10 nanofarads, quickly and clearly. Another electrolytic capacitor for 2200 microfarads. After some thought, the multimeter outputs 2264 microfarads. I want to check the resistance of these probes. Approximately 0.06 ohms. An excellent indicator and very high-quality probes. The F3 button turns on the current measurement mode. The device suggests that you need to switch the probe to the appropriate socket. I'm measuring how much current the LED strip consumes. I'll connect it to the power supply. The current strength is 290 milliamps. 296. When the current measurement mode is selected, the F4 button can switch to the low current measurement mode up to 200 milliamps. But if you press the F1 button, that is, voltage measurement, or F2, then you can already use the F4 button to select the millivolt measurement mode and also temperature. To measure the temperature, instead of probes, you need to connect a thermocouple. The temperature is increasing. The thermocouple is working. Using the hold button, you can fix the measurement value on the screen. resistance at 47 kiloohms. Just as in the oscilloscope mode, a long press on the Hold Save button saves the screen image to the device memory. Pressing this button for a short time turns on the relative measurement mode. So, what conclusion can be drawn? The ZT702S digital oscilloscope is a wonderful device. Both in the oscilloscope mode and in the multimeter mode, it makes accurate and fast measurements. A lot of settings, its functionality and ease of operation make this device one of the best in its price category. And in some moments, it even wins against more expensive oscilloscope models. The ZT702S is a very high-quality device for an affordable price. This concludes this video. If you liked it, then click the subscribe button so as not to miss the new video on my channel, which will appear very soon. I thank you for watching and see you soon.